and usually we are talking about 10, milliwatts kind of operation. And for BLE, it's doing better. It's like hundreds of microwatt. But the radio we designed, which we call the quench, and it's written, it's called the Q radio here. For obvious reasons. So basically, the Q radio we designed, it can do at least an order better than the best radio, the best BLE radio on the market right now. When we combine this capability with Wi-Fi or BLE, then basically you can really, really lower the bottom, rock bottom power consumption by an order. Okay. And on the graphic side, basically we are looking at again hierarchical ways of using the GPU design, and basically for ambient mode where the user is not interacting actively with let's say your watch, and as compared to the active mode where you have to render the images more quickly, you can use a 2D and 3D GPU. For different modes. The final bullet here is something, kind of trivial, but this is something useful for a small display thing. Basically, you can, you don't have to generate very high, accurate, high resolution pixels, and you can do some lossy compression as well as one of the tricks we tried. As I'm running out of time a little bit, let me cover this topic a little bit. So basically, so the other thing we did is basically for hardware, as we know, hardware accelerator makes a lot of sense for the always-on functions with streaming workloads. One example here is the keyword, activation kind of mode. Everybody knows OK Google, and Qualcomm Snapdragon supports Hey Snapdragon, and it basically will wake up the device. And this kind of function need to be constantly on the audio part, and the processing need to be constantly on. And it makes sense, at least in some of the cases, to design a specified hardware accelerator to lower the power consumption. So anyway, so let me jump to the result of our experiment. So we looked into, again, from bottom-up approach, look at memory, look at all the tricks we can put together, and designed a test chip. And we tape out the test chip, and we try to see how well we are doing. And basically, this is some numbers here. As I mentioned, in the rock bottom case, you are spending tens of microwatts. This is unheard of before basically, this chip. And it supports actually a variety of functions. As I mentioned, it can do sensor processing, the pedometer. This is one of the very popular use cases for wearables. And the CMC, which is motion classifier, heart rate monitoring, and tilt detection. And it can also do, always-on keyword detection. And we can run all these things in this chip, okay? And on the radio side, as I, this audience is probably more radio-oriented. So this is the quench radio we designed, and if you look at it, basically the power is again also in the order of 10 microwatts, which is much better and order better actually even as compared to BLE, the lowest power receiver design on the market. So with that, I will conclude my presentation and open to the questions.
Time for maybe one or two quick questions. Any questions here from the audience, the present audience in the back? Yes, there are.
So how would going to like FDSOI technology or something that gives you very low leakage change the picture completely, or wouldn't it?
Well, absolutely. Basically the low always-on power, a significant fraction is coming from the leakage, and if you can get rid of it, it will change the story quite a bit, basically.
I guess one thing, I mean, can you clarify, in your view, like the role of wearables and 5G, how they're connected? Maybe you could tell a little bit of that story.
5G basically, as I said, it presented a very different category of requirements. Basically, the data rate is probably not that high, but you need the super low power consumption. So in the 5G standards, basically, especially, right now cellular IoT is also being examined. And I'm pretty sure it will become the element of 5G. So in this design, we have to take this, requirement into account and design the radio very, very carefully so that, it can support this kind of low power consumption. So the power consumption partly, of course, coming from the hardware side, which is the focus of my talk today, but it also comes from the interface design. So, probably a very carefully designed hierarchical interface makes sense. We can, introduce multiple stages of communication and really, really lower the duty cycle, these kind of things.
Okay, excellent, thank you. Thank you, Shinjo. Okay, that was great. And so we're continuing our theme in the morning here with looking at a second interesting application of, good, we have the right slides here, 5G, which is in for